In this video, we are going to be looking at some basic formulas for variabilities in biostatistics. In biostatistics, the word variability refers to the extent to which data point in a data set differs from each other. There are several measures in variability commonly used in biostatistics. We have the range, we have the variance, we have the standard deviation, interquartile range, and we have the coefficient of variation, which is CV. In this case, we're going to focus on some of the basic formulas, which I'm sure we're going to find it helpful. And at the end of this video, I'm going to drop a link down below. And in that link, I solve some basic problems that has to do with biostatistics. Okay, let's dive in and see how we can do that. The first one is, let's start with sample mean. Sample mean is being denoted by SM. X simply means, okay, the X bar is actually mean. And in this case, the sample mean, which is X bar, is going to be the summation of X divided by N. In this case, notice that this is what we call the sample mean. And this is the formula. And this is summation. That is summing of all the values. What about the N? This simply stands for the sample size. Okay, let's go on and try the next one. Next we have is population mean. Let's say population mean is being denoted by mu, which is going to be the summation of X divided by N. If you notice, this N is more like capital, not like that first one. In this case, this is what we call the sample mean. Sorry, population mean. That is if we are dealing with people. Population mean being denoted with mu. And this is summation of the values we are giving provided. That is the summation. That's this first one. We keep on adding depending on the numbers of the values. And this N we have is the numbers of people. Okay, let's try the next one. So in this case, notice that, let's go back to the first one. Notice that there is a bit explanation which I need to give. In the sample mean, it's simply the average values of the sample calculated by summing all the values and divided by the sample size. Therefore, we said the sample mean is simply going to be X bar divided by the summation of X divided by N, and this is the formula. What about the next one? In this case, population mean is simply the average value of the entire population calculated by summing all the values and divided by the total population size. In this case, it's been denoted by mu, which is going to be the summation of X divided by N, which is almost more like that first one. Okay, let's see if we can try the next ones. Let's try something like sample variance. Sample variance is going to be SV, but it's been denoted by S most of the times. That is, sample variance is going to be the summation of S minus S bar divided by N minus 1. In this case, this is what we call the sample variance. If this is sample variance, the S is simply going to be the values given, and this is going to be our mean, and this is going to be the sample size, right? Or population size, but remember we have minus 1. We have size but minus 1. So, but in this case, we can just write it differently. Remember, most of the times it has to be in square root. In this case, we're going to have, if we have S squared, that is sample variance in square root, is simply going to be the summation of S1 minus X bar to the power of 2. We're going to plus that by X2, depending on the numbers of the values which we are given, X2 minus X bar to the power of 2, up to xn plus x bar to the power of 2. We are going to divide that by n minus 1, which is almost this, and this side is something. In this case, you need to understand that a measure of how, sample variance is simply a measure of how a spread sample is being calculated. It's being calculated by simply summing all the squared deviations from the mean and dividing by the sample size. Then we are going to minus that by 1. This is what happened here. Okay, let's write the formula and take a very quick example. We said the sample size is going to be sample variance, which is going to be the summation of x minus x bar. We are going to divide that by n minus 1. Let's take an example. Let's say we are given an exam score, and that exam score is given 10, 20, 30, 40, and 50. Notice that this is 1, 2, 3, 4, 5. Remember, this is 40. Right? For us to find the sample variance, we're simply going to do it this way by saying 10. No, first of all, we need to find the mean. For us to find the mean, which is x bar, is simply going to be 10 plus 20 plus 30 plus 40 plus 50. That is 5 divided by the total number, which is 5. I assure you, your mean is simply going to be 30 if you do the right thing at this point. What about the sample variance? For us to find the sample variance, we're simply going to be using this formula. Remember, this is mean, and the formula we use to find the sample mean is x bar divided by the summation of all the values divided by the total number, and it gives us simply 30. What about the sample variance, which we said is simply going to be the summation of bracket x minus x bar divided by n minus 1. We're going to plug that into this equation to find our problems. In this case, our sample variance is simply going to be 10, which is x, which is the given values. This is x1, x2, x3, x4, till infinity. This is xy. In this case, x1 is going to be x minus, what are we minusing from this? We are minusing our mean, which is x bar. In this case, our mean is simply going to be 30 to the power of 2. We're going to add that by the next one, which is 20 minus that same 30 to the power of 2. Up to the last one, which is 50, and divided by n minus 1, which is 5 minus 1, which is simply going to be 4. And if you do that correctly, feel free to punch on your calculator. Your final answer is simply going to be 100. Okay, let's see if we can try the next one. Alright, the next one is simply going to be population variance. Population variance, most of the times is being denoted by sigma. A sigma is simply going to be the summation of bracket x minus mu divided by n. In this case, don't get left out at this point. This is simply the values, given values. And you already know the mu is simply our population mean. And here we are given the number of population. So if you had a population, all the students in a school, right? The population variance will be the sum of the square deviation from the population mean divided by the total numbers of the student. What I'm trying to explain here is this formula. We say the population variance is denoted by sigma. If that is the case, sigma is simply going to be the summation of x minus mu divided by n, and this is the formula for sigma. The last but not the least is standard deviation. Standard deviation, how can we solve this problem? For the standard deviation, most of the time it's been denoted by SD, which is standard and deviation, which is going to be the summation of, square root of the summation of x minus x bar divided by n minus 1. The square of the sample variance, which provide a measure of the spread of the sample. Remember, if this is standard deviation, sometimes we will be asked to find the population standard deviation, which is a little bit different. The standard population, that is for population, standard deviation for population is simply going to be sigma, which is going to be the square root of summation into bracket of x minus mu divided by n. The square of the population variance, which provides a measure of the spread population. And this is it for this problem. I hope you find it helpful. First, like, share, and subscribe. And for you to understand or use this formula properly, I'm going to drop a link below, which has to do with one solution under the biostatistic. It's actually a table. All right, thank you, and see you next time. In this video,